So now we could get into the next talk for today. The next talk for today is from Grant Gelven. It is also very much in the graph analytics side of the house as well. This particular talk is entitled Graph-Based User Entity Behavior Analytics for Enterprise Insider Threat Detection. So without further ado, I'll pass it over to Grant for his talk here.
Thank you. Everybody hear me okay? Thank you for the inspiration, Sean. I like to pace also. So thanks so much for being here, guys. I had the wonderful pleasure of meeting Arjun last night, I promise. We did not collaborate on these talks whatsoever, but I think you'll find that there is a very natural format for discussing how we address these graph analytical problems. So I am going to talk about a lot of the similar things that Arjun did in terms of audit logs and converting them to graphs and building models and predicting behavior. But we're going to talk about it here in the context of insider threat detection. A little bit about me first, though. I'm a data scientist embedded in security at Stripe. I've been a data scientist for about 10 years. And for the past 5, I've spent a lot of time focused on operations-shaped problems, incident response problems, not always related to security, but for the past 2 have been focused on security and threat detection in particular. A brief agenda, what I do want to cover, although thank you, Arjun, we may be able to breeze through some of the preliminaries, but I'll provide some motivation and a problem statement with a few definitions and some industry statistics. Then I want to dive into the kind of conceptual and mathematical framework for quantifying risk, right? Because that's really what this talk is ultimately about. It's how we use graphs to generate risk-based metrics and then use that to enable our security operations for insider threat risk management at Stripe. I'm going to talk about the individual components of quantifying risk in terms of modeling user behavior, using audit logs and graph analytics. Our resource prioritization impact, which really puts a relative value on all the internal assets that we're trying to protect. And then I'll discuss the output of this model, which we internally call the access risk score, and we use this as a high level metric to help guide security operations, but then also policy and the allocation of resources. So first off, I want to provide this simple definition, right? No surprise to anybody here in this room, but I do think there is one important thing to point out that makes the insider threat landscape a little bit different than some other security domains. And it's namely that the actor has the authorized access, right? In a lot of security situations, roughly speaking, you build a wall, and if there's a hole in it, that's pretty easy to detect. Well, in this case, the actor is already on the other side of the wall. So I think it makes for some subtle nuance in solving this problem. Makes it a bit more difficult. I also think a bit more interesting at times. But to give a little bit more motivation, the Ponemon Institute has been doing industry polls for the better part of the last decade or so, reaching out to companies across the globe and across verticals to see how they're dealing with insider related incidents. A few things. There's definitely been an uptrend over the past 5 years, and according to this survey, just last year, you have a super majority of enterprises in the survey that are seeing on average almost 2 per month. Right, and this comes at an average annualized cost in North America of about 17.5 million, and in the financial services, which is Stripe's vertical, right? This increases appreciably, almost 20%. Finally, the insider-related security incidents are pretty complex. They take a long time to resolve, the better part of a fiscal quarter most of the time. And only about 12% of the time can you resolve them in under a month, but it's certainly worth it, right? It'll cut your cost in half on average, over the course of a year. So that gives us a lot of motivation to invest in an insider risk management program at Stripe, and detection and efficient response is a key cornerstone of that. So in order to do this, we looked at how can we quantify our risks, across all of our internal assets at Stripe, and set up a program to monitor and mitigate some of these risks. Now, I want to start with just conceptually, how do you go about quantifying risk? Usually, in its purest form, risk is just exposure to uncertainty, right? So, if you're going to calculate some metric, it's going to be some impact weighted probability or likelihood of some event occurring. So, in the case of an insider risk, right, we're going to take a very simple form and consider it the product of two terms, right? So the likelihood of a bad event occurring, and that is naturally going to be a function of an insider, right? So the actor S and the resource that they're acting against, right? So in this case, that resource could be everything from an internal document. It could be a database table. It could be an S3 bucket. It could be an internal application, right? It kind of all things are in play here. And the second term is going to be the resource impact, right? So this is more or less a function of the value or the sensitivity of the resource that's in play. So why don't we dive into each of these individual components? Okay, the first of which, the likelihood term, we're trying to assess the risk or the likelihood of something bad happening, right? And that bad thing is going to be an action that somebody takes, not necessarily maliciously, by the way. And so either way, we need to come up with some sort of model to predict user behavior. And the way that we do this is we're going to use audit logs as well, right? And actually a quite heterogeneous set of audit logs that we kind of put into this simplified universal data model that I'm showing you here. But we have audit logs from dozens of internal sources that we aggregate into a single place over some fixed historical time period. And they all take this particular shape where you have some actor, some action that they take, the resource that they take it against, and then some metadata associated with it. Now, given this particular shape, it's pretty straightforward to then transform this into a graph naturally, right? And so then the problem of modeling user behavior becomes, given some historical average of what people do, can we predict what they're going to do tomorrow? So can we predict the links in tomorrow's graph or today's graph, right? In the case of security operations. So the way that we do this is, every graph is equivalent to its adjacency matrix. And in our particular case, right, we'll aggregate over some small time interval, say a day, say an hour, and then we'll take an average of that over a larger historical time frame to give us a average approximation, usually over some like fiscal quarter, of the actions that every single individual takes against every single resource that we care about monitoring. And once we have that adjacency matrix, right, we can learn, so to speak. We can use some classical machine learning techniques, specifically matrix factorization, to generate a parameterized representation of the average historical user behavior. Now, in doing this, this is interesting, and I like the simplicity here, mainly because of the efficacy in our case. But if we use a non-native matrix factorization and we make the right choice of normalization and loss function when we're performing the factorization, this makes it equivalent to a PLSI, to use the NLP parlance, right? So basically, we're treating all users as a bag of actions, right, that they did over the past quarter. And then given that parameterization, it's pretty straightforward then to make a prediction, right? So we have this latent representation. We take a look at everything that you did today. That's the expectation, right, of your past behavior, and is it similar to what you did today, right? So what we find with this model is that it's pretty easy, trained on roughly a fiscal quarter's worth of data, to predict what you're going to do over the course of the next week, with a decently high F1 score. So 4 out of 5 times we can predict what resources you are going to access over the next few days. So how does this really factor into, this risk assessment, right? Ultimately, we want to be able to get some measure of uncertainty, right? Or some likelihood that something strange is happening, right? So if we trust our model and its ability to predict what you're going to do, right? Well, everything that doesn't match what the model says, right, may be considered strange, right? So we're going to take the complement of what the model thinks you should have done today. And then that is more or less your anomaly score, right? So it's the likelihood of a potential anomaly occurring. So it's a direct measurement of what your past value or your past behavior and how you're deviating from it. So the next thing we want to talk about is the resource impact framework. Now, this is more straightforward, but it is worth touching on. Ultimately, when you have this risk metric, right, you want to be able to judge in terms of the actual loss that you may accrue, right? So you can put units on this. You can put any unit you want. We at Stripe, we were not comfortable with putting absolute value on it just yet. So we actually keep this unitless and we just put a partial order on it. And the reason being is because we say, I don't know exactly what a database table is worth if it gets exfiltrated, but I do know if that database table just contains benign operational data, that's probably 100 times less sensitive than non-public financial information, right, that is only going to be given to, our board or our investors. Right. So we're comfortable with, apologies. We're comfortable with putting these relative impact values on our various internal resources without any units. And so when you combine these two things, we get our access risk score, which to give a definition, right, this is a quantitative measure, a unitless quantitative measure. So it's an index, right, of our residual risk to an insider breach based on the assumption that, people's job duties are relatively predictable and the way you've been acting over the past quarter is a pretty good proxy for what you're going to do tomorrow. Okay, and ultimately, you can calculate this in a lot of different ways, given those two quantities, but the most common one that we use is this, right? So we look at the daily aggregation of every user's activity, and then we actually end up weighting it by the maximum impact value, right? So if you spent your entire day accessing documents that are already in the public domain, your risk is 0. We don't really care about that, right? But if you spent your entire day moving money around for one of our merchants, then we're gonna pay attention to that the most. So this is one of several ways that you can calculate this. And another thing to point out is while we do this kind of by default in our monitoring, this score is composable, right? So you can roll it up to any dimension, right? You can roll it up to a set of users. You can roll it up to a set of resources. And in a minute, I'm going to talk a little bit about how that can be used to provide security guidance. But just to give you some intuition of, what this looks like in reality, I actually took this snapshot from one of our operational dashboards just yesterday morning. And this is an intuitive shape of this distribution, right? You'd expect the vast majority of people to have a very low risk, right? Everything they're doing is quite predictable. And then you have this long tail of various types of anomalies potentially that may be occurring. If you want to be precise, the vast majority of users, about 90%, day over day, we can predict what they're going to do to within about 18% in terms of the assets that they access. So before we wrap up and talk about the application to security operations, I do want to ask you guys. So what do you guys think? A quick case study here, just for fun. So who do you all think is more predictable, a data scientist or an account executive? Any takers? Wow, that was unanimous, right? That was wow. I am in a room full of data scientists. So here, what I've done is I've taken a look at the last quarter of the weekly averages of these two core cohorts of internal users, right? And what you can see is that the average risk of a data scientist is actually quite high, compared to certainly a account executive, but the mean, right, is down here, right? So the vast majority of the company is much more say, or much less risky, I guess I will say. And this makes sense, right? Intuitively, a data scientist is usually given broad access to a lot of data, a lot of systems. They're doing a lot of ad hoc research. An account executive is getting access to a small number of tools, right, that's used to do their job function, which is usually enabling our merchants, right? And it's a specific set of merchants at that, right? So they're kind of doing the same thing day over day over day, right? Yeah, I thought that was fun. I even showed my wife this, despite what she thinks, data scientists are not predictable. All right, so all right, I want to finish up real quick. I know we only have a few minutes left. Talk about the security operations. So, given our risk or access risk score, there's kind of three pillars that we've shaped around this metric, and derivatives of it. And the first of which is monitoring detection, which we touched on a little bit, and we'll dig into more. The second, which is it was not originally intended to do so, but we've actually found it very useful, is in response and investigation, not necessarily to a direct insider incidents, but even things where we're looking back historically at, say, how permissions change, right? If we're going through audits and whatnot. What you can do is if you have to go sort through millions of rows of data to see if people that may have had access to something had the appropriate business justification, you can use this actually to rank and prioritize and filter and really reduce your audit and operational burden or your investigations. And the third, and what I think is perhaps the most interesting, is you can use this metric really to provide targeted guidance on where our weaknesses are from an insider threat perspective, and where the most important place to kind of focus our limited security resources on. So here's a brief overview of kind of the system architecture for generating this. Over on the right hand side, we have our source of numerous distinct audit logs, and we bring them into a single sandbox that's isolated to within security, where we're aggregating them, turning into our goal graphs, running them through our model training and experimentation workflows, serving them, running inference, and then down here at the bottom, this is really where the operation, this is where everything kind of manifests, is outputting the score daily, generating alerts and detections, providing tools to enable fast response and investigation, as well as reporting and that forward guidance for leadership. But to touch on each three of these, monitoring detection, the simplest form of a detection, right, is we have this daily distribution. We compute this a couple times a day. Let's go examine outliers, right? If we have security policies that warrant examining this type of behavior. The next of which is, right, remember our audit logs, right? This is the original source. While our metric that we kind of keep track of is an aggregate, right, of a person or a group over some time frame, the model is scoring at the event level, right? So as soon as we go to, like I mentioned, some sort of audit or some investigation, we have these audit logs now where we can rank, prioritize, and filter at the event level. to really highlight what should be interesting, what we should pay attention to. And this has really helped out our security analysts quite a bit. And then finally, I want to walk you guys through a quick thought experiment on forward guidance. So, we all ascribe to least privilege, right? It's the unicorn that we can't always chase in security. You're never really going to get there, but how do you know how far away you are? And I'm claiming that here's a pretty good measurement of how far away you are from least privilege, if you want to try to get there. So performing non-negative matrix factorization to first order is equivalent to a chi-squared statistic, right? So we have a statistic that we can test, right? So we'll choose some significance level, right? And see if any one person's behavior or group of people's behavior is significantly different from what we do expect, right? Equivalently, you can test the difference right here. So all we have to do is calculate that p-value, right? Well, this is actually trivial, right? Because we actually already did it. It's just a likelihood term in this risk score, right? This 1 minus p here. So in that case, let's think about what does it mean to be least privileged, and let's remember, what's it mean to have an inside actor? Well, they already have authorized access, right? So there's always some finite probability, even if you're in a least privileged environment, that an insider related incident is going to occur, right? Now, I don't know what that is. It's probably different for every organization, right? But if you can estimate what that is, then why not just choose that probability to be your confidence, right? In which case, then we have calculated the likelihood, right, for every single insider or every group of resources that you want to protect. In which case, anything greater than P sub I, consider that a budget. Then if it's constantly above P sub I, then that is not least privilege, and you need to be changing something. Okay, and this is useful with this particular score, right? Because once again we can roll it up anywhere, right? It can be a group of people, it can be a group of assets, and here's kind of a characterized representation, my trivial mental model of what this looks like. It's not to scale. Well, thank you very much. That's about all that I have. I do think we have a few minutes left for questions.
Great talk, thanks. So your likelihood term is computed solely from the user to resource interaction history and not from the features on users or the resources. So how do you generalize to a new user or a new resource?
Yes, the cold start problem. Of course. We deal with that the old-fashioned way. When it comes to users, we actually kind of got that for free at Stripe. We have a really robust onboarding program. What we call spin up, right? Where every single user is at the company for 2 weeks, kind of shadowing their job function, right? And even doing some releasable work, their spin up project, right? So basically brand new users, and these are a serious source of false positives early on, right? We'd never seen you before, so everything you do, there's zero probability, right? That is the cold start problem. So now we just wait till we have a little history for users. Now for resources, it's a little bit more subtle, right? In which case, then we will actually adjust our training intervals sometimes, dependent on the frequency with which we see updates. Things like database tables are persistent, right? Over quarters, years. Things like Google documents, right? They come and go all the time. And so you do have to address those.
Hi, you mentioned you're a data scientist embedded with security.
Mhm.
So, broadly, are there things you wish security practitioners would spend time learning to meet you halfway?
Um, no, meeting me halfway, I don't know. I'm actually fortunate at Stripe. Um, it, for all the data scientists in the room, you probably run into this at some point in your career. Sometimes there is skepticism. Sometimes it is a bit of an uphill battle. You do have to be a salesman, so to speak. Um, eh, you know, at Stripe, I've not encountered that, right? They've been actually excellent partners. They've been very enthusiastic about seeing how we can use data science and machine learning to better enable their operations. Um, in terms of learning, though, I do think that is important because I think there is like kind of a base statistical skill set that is useful for most security practitioners to have. And so, I do run some reading groups and provide resources and meet with the team members, anybody who's interested to, talk about everything from, big data processing to statistical hypothesis testing to ML.
Well, great. Thank you so much for this great talk. Please go ahead and give him a round of applause.